Here we're looking at example 2 from our 2-7 set of notes. We're asked, what are the equations for these absolute value graphs? Well, first of all, before we can dive into things, let's go ahead and identify what is in fact our vertex. So we can at least find our vertex. It's pretty much the easiest point that we can actually identify when we're looking at these absolute value functions in terms of their graph. We can see that at this point right here where that v kind of meets, that's going to be our vertex. And we see that it happens to be at negative 1, 2, 3, 4, 5. So negative 5, comma, negative 3. So even before we actually constructing the equation, let's go ahead and identify some information. So our vertex is negative 5, negative 3. Now from that, we notice that this shape is opening upwards. We have our v opening up. And with that, from our vertex, we are going up 3 over 1 to get that point such then that it opens up. So it looks like our slope, or a, is going to be up 3 over 2. Now our a is also considered to be negative 3 over 2. And where that comes in is as you're approaching your vertex from our left side. So we can see that we're going down 3 over 2. That's where this slope comes in. The positive 3 over 2 is right here. You're going up and to the right too. So we have our a and we have our vertex. All we need to really do now is go ahead and construct our equation from this information. So again, we have y equals, we know that there's going to be an absolute value in there. And there's some stuff around here. Well, let's go ahead and focus now just on the inside. Well, we have some x, and we know that our vertex is negative 5. So inside, again, we take the opposite of what our vertex is saying. So since this is negative 5, inside of our absolute value should be positive 5. Our k, which is right here, we take him just as he is. So it says negative 3, we then end up with negative 3 on the outside. Now for the slopes, again, that's controlled by our a value, which is in front of our absolute value. Well, here they are. We're going to go ahead and use the positive 3/2, again, because our v is opening upwards. It's opening up positively. So we have y is equal to 3/2 times the absolute value of x plus 5 minus 3. That would be our equation for this first one. For b, it's kind of the same idea, same exact set of steps. We first identify the vertex. So it looks like our vertex happens to be at 2, 0. For our slopes, we see that this thing is going downwards. And because it's going down, looks like 4 over to the right 1, our slope would be negative 4 over 1, which is the same thing as saying negative 4. So again, we can see it going down 4 over 1, so that slope is negative 4, but we also have the positive 4 as our slope as we're approaching the vertex on the other side. So really our a is negative 4 and positive 4. Our slopes are, I should say, negative 4 and positive 4. Now we have the necessary information we need to go ahead and construct our equation. So we have y is equal to, there's going to be some absolute value in this, because we have a v. And inside that absolute value, let's focus on that, where we have our x, and we're going to go ahead and throw in something right near that x. Well, for our vertex, again, we just go ahead and take the opposite of what our x variable is saying. In this case, since it says positive 2, we're going to go ahead and write negative 2. For our k value, that just comes from our y. In other words, just comes out to be 0. So really, we have this absolute value and we're adding nothing to him. The slopes are controlled by the a value in front. Well, here they are, negative 4 and positive 4. Now again, because this v is opening downwards, we're going to go ahead and use the negative 4 as our slope. So it looks like our equation comes out to be y is equal to -4 times the absolute value of x minus 2 plus 0. You really don't have to have this plus 0 at the end, but I was just kind of writing it there for effect for that k value. But again, though, that is example 2 from our 2.7 set of notes.